We're now going to apply our new substituents to an example, and you're still going to follow the same basic rules. We find the longest continuous carbon chain. So I'll start here. I highlight to here. And now if I go up, I can capture 2 carbons. Or if I go down, I can capture 2 carbons. Well, if I go up, I have 2 substituents coming off of that portion of the parent there. Also, I have no idea how we're going to name this part either, because that's quite complicated. So what if we go down instead? That's actually better because we have more substituents attached. We have this and these 2. So that's going to be our longest carbon chain. Now when we figure out what end to number from, if you start on the left side, you'll have 2 things at carbon 2, but you don't run into your next substituent until carbon 6. Versus if I start here on the right, I have the 2 things at carbon 2, 1 thing at carbon 3. So that's a better numbering scheme. 8 carbons is octane. Let's go through and identify our substituents. Here at carbon 2, we have chloro groups. There's 2 of those, so we need to include both of them. We have 2 chloro and another 2 chloro. In order to include that, we write the number for each, even though they're on the same carbon, 2,2-dichloro. So the di tells us that there's 2 of those. If you're using the di prefix, you better have 2 numbers in front of it, even if that number is the same. Next we have on carbon 3, this we just learned is an isopropyl group. And then at carbon 7, we have 2 bromos. So we put those together and write 7,7-dibromo. For alphabetizing, we're going to use the B in bromo, the I in isopropyl, and the C in chloro. So the B comes first alphabetically, so our name starts 7,7-dibromo. Then we have the C for chloro, so we write 2,2-dichloro. Then we have the I for isopropyl, so we write 3-isopropyl. And the parent is octane. And that's our systematic name for this compound. So questions I often get with this usually revolve around numbering and how to pick or break ties. So I want to show you here just a couple of common scenarios and how to deal with them for numbering purposes. All right, let's say you're given this molecule here and you find your longest carbon chain. And one mistake people often make is to say, well, there's a lot more going on down here, so we need to start from this end. We need to do this systematically, not just take a quick glance and try to figure it out. The other thing, sometimes people say, well, chlorine is a halogen, that should be the carbon, or they'll say the C is better than the M in methyl. No, we just looked at the first substituent, and we think, well, what's better? Start here and have one thing at carbon 2, or is it better to start on the opposite end where I have 2 things at carbon 2? There's no need to look any further. We can make our decision just based off of what's at the first branching point. And 2 things at carbon 2, that's better, so that will be our numbering scheme. Like that. Okay, how about in this case? If we number from the left, we have something at 2 and something at 5. If we number from the right, we have something at 2 and something at 5. We have an absolute tie in either direction. Only when you have this type of tie that you can't break through numbering. Your last resort is to use alphabetical priority. And in this case, we compare the B in bromo versus the F in fluoro. The B wins. So we use the numbering scheme in green as the correct scheme. But only use alphabetical as your very last resort if you can't break it from anything else.